Let's do a quick conceptual review of what we are learning so far. What I find helpful is to cycle back and forth between formulas and the math side and then the conceptual side where we're explaining in words what's going on. And so that's what I'm going to do here. This slide is titled Bivariate Correlation Review, and bivariate again just means two variables, so bi, two, and variate, variable. And so we're just talking about two variables, correlation or association between two things at this stage of the game. Okay, so first question, what is variance and how can it be standardized? Variance is really an index of the extent to which there is diffusion of the data points around the mean. So if we have, for example, a quiz that we would give in class, let's say, and some people did very, very poorly, some people did extremely well, and everything in between, that would be a lot of variance. If everyone basically did pretty well, then we would have low variance. So it's just this extent to which there is deviation from the mean in the sample. So remember that variance is literally what we learned in the NFL slide. It's literally the average of the squared deviations of each score from the mean of the sample. We standardize variance by creating the standard deviation, and we do that by taking the variance and then we take the square root of it. So that is how we can compare variability across studies. So variance, remember, is tied to the metric, the specific metric of the study. And so we can't compare variances across studies, but we can compare standard deviations. And that's wonderful because it just gives us a great index of variance that we can use when making those comparisons. Covariance, remember, is an index of the strength of the association between two variables, and we standardize that by, remember, dividing by the product of the standard deviation of x and y. And so we would make the correlation in that case. So remember, correlation is just a covariance that's standardized. Remember, covariances we can't compare across studies, but correlations we can. So a correlation of 0.3, it means the same thing across any study that is done. And a correlation of 0.3, when we would square that, would be 9% of the variance, and so that's, again, another standardized metric effect size that we can use to compare. All right, so we have the mean, variance, and standard deviation of a standardized variable. So when we standardize everything in our maybe all of our data points by taking z-scores, then when we look at their mean, you can do this in SPSS and make sure that this is true, the mean will be 0. So the mean is going to always be 0, and everything is in relation to 0 then. And the variability is going to be 1, and the standard deviation is the square root of 1, which is 1. And so that's how it always is when we take our sample and all the data points and make them into z-scores. We'll always get a mean of 0 and a variance and SD of 1. And finally, the sum of values for standardized variables. So if we standardize all of our data points and we add them all together, remember, half of them are going to be negative because they'll be below the mean, and the other half will be the positive and above the mean. And so we're going to add all those together, and just like we did in the NFL player example, they're going to sum to 0. So whenever you're adding all these deviations from the mean, if you don't square them first and take care of the issue, they'll always sum to 0. So just some things to keep in mind and review as we move forward.